Good morning. I hope you're having a good day. I hope you had a good break. And I am currently at a district meeting, so I thought I'd put a video together for you just so that you could better complete the assignments for today. Our objective today is to be able to use the periodic table to identify the numbers of protons, neutrons, and electrons there are in atoms that make up elements of the periodic table. So, if you would, open your interactive notebooks to page 14. And we're going to put this information into our interactive notebooks. Notice that today's title is Introduction to the Periodic Table, and this is on page 14 of the notebook. So why don't you go ahead and pause the video, open up your notebook, and copy down what's already on the page, and then as we go through the video, you can continue adding stuff in. Okay, welcome back. So I assume you've already copied everything down because you just paused like I asked you to. Let's go ahead and talk about these symbols on the periodic table. If you'll notice on Blackboard, just below this video, I've embedded a periodic table for you. So you can reference that, or you can reference the pictures that I have on the board here when we're talking about different elements. Okay, so let's talk about all of the different things that show up in a block or a box on the periodic table for a certain element. This particular one is looking at the element carbon. So we notice there are 4 parts to the little box that carbon gets. So it tells us everything we really need to know about carbon as far as the element goes. Okay, so we've got the element name, carbon, and its symbol, capital C. Just a little side note, if an element has a symbol that is 2 letters, the second letter is always lowercase. For example, lead over here, its symbol is capital P, lowercase b. That is hugely important, okay? We would never ever write lead as capital B with a capital P. That is wrong. That's actually a compound between phosphorus and boron, okay? So that is not the same thing as the element lead, capital P, lowercase b. Okay, so let's go ahead, we'll go back. So we're looking at carbon, and we said its element symbol is capital C. We have an atomic number of 6 and an atomic mass of 12.01. All right, these numbers are hugely important, so let's talk about what they mean. The atomic number for any element is going to give you 2 pieces of information. Piece of information number 1 is the number of protons. And I like to abbreviate protons with a lowercase p and a plus sign. Just makes it shorter, and it helps me remember that protons have a positive charge. Okay? The atomic number identifies the element. I know that carbon has 6 protons because of its atomic number, and I know that if I'm talking about element number 6, that I'm referring to carbon. Not oxygen, not nitrogen, not fluorine, but carbon. Okay? So the atomic number, first of all, gives me the number of protons. The atomic number also tells me the number of electrons, because atoms are neutrally charged. They don't have an overall charge. So their number of positive charges has to equal the number of negative charges. That's really important as well. Okay? So for an atom of carbon, there are 6 protons, and there are 6 electrons. So the atomic number tells me the number of electrons. And I abbreviate that with an E and a little minus sign. Uh-oh. There we go. Sorry about that, goofing around with my Mac. Okay, so our atomic number tells us 2 things. It tells us the number of protons and the number of electrons. This number is the same in an atom of an element, because that atom is neutrally charged. 6 positive charges to balance out 6 negative charges. Okay? Next we have the atomic mass. Now this number has a decimal with it, and that decimal represents, or that number as a whole represents, how heavy the nucleus of the atom is. Okay? So the atomic mass tells us how heavy the nucleus of the atom is, but more importantly, it tells us how many protons and neutrons there are together. Alright, so the atomic mass is really the number of protons plus the number of neutrons. and I abbreviate neutrons N with a little 0 because neutrons don't have a charge at all. Protons are positively charged, electrons are negatively charged, neutrons do not have a charge. Okay? So if we add up the number of protons there are in an atom of carbon, and we add up the number of neutrons there are in an atom of carbon, we get a number, a whole number, that's close to 12.01. Okay, so when we're talking about atomic mass, if we want just the atomic mass, we give it as a decimal. But if we're talking about figuring out the number of protons or the number of neutrons, then we're going to round it to the nearest whole number. And that'll become important for this step right here. So if we take the atomic mass rounded and we subtract from it the atomic number, that's going to give us the number of neutrons. Okay, so I will show you what that means. And of course, at any time in the video, if I'm going too fast for you to write things down, just pause it, copy down what you need to copy down, and then restart it. Okay, so looking at this little table here, I use the information from the periodic table about carbon to help me fill in this table. So I'm looking at carbon, it has a symbol of capital C. Based on the atomic number, I know that there are 6 protons and 6 electrons because carbon's atomic number is 6. Okay? To determine the number of neutrons, I can't just use this number. I had to plug these two numbers into this formula. So what I did was I said atomic mass rounded of 12 minus the atomic number, and that's how I got 6. That tells me, so this was the atomic mass, this was the atomic number, and this is the number of neutrons. Okay, so it just so happens that in an atom of carbon there are 12 protons and electrons, but there are also 12 neutrons. This is not always the case, but for carbon it is. Okay, so filling out my table, I had the element carbon with the symbol capital C. The atomic number told me there were 6 protons and 6 electrons. And by doing math, by saying atomic mass minus atomic number, I was able to calculate that there were 6 neutrons. And just for a little extra, I helped myself out to remind me that the atomic mass was 12. That's the rounded atomic mass. Okay? Let's do another one. Let's look at the element with the symbol S. So if you look at the periodic table that's sitting below this video in Blackboard, and you find element S, you'll see that that element S is really sulfur. Okay, so the symbol for sulfur is capital S. Let's go ahead and write the element name down in our chart. So element S is what? Good, it's sulfur. Okay? Based on the atomic number, first of all, what is the atomic number of sulfur? Is it 16 or is it 32.065? Perfect, it's 16. Okay, so based on the atomic number of sulfur, we can figure out how many protons and electrons there are because the atomic number of sulfur tells us, point blank, there are 16 protons and there are 16 electrons. Okay, so let's fill that into our table. We've got 16 protons and 16 electrons for our element sulfur. Okay, now we need to figure out the number of neutrons. Okay, so we are going to say the atomic mass of sulfur minus the atomic number of sulfur to get the number of neutrons. Let's try that out. The rounded atomic mass for sulfur is 32. The atomic number for sulfur is 16. When I subtract 32 minus 16, lo and behold, I get the number 16. So how many neutrons are in the nucleus of an atom of sulfur? 16. Once again, in sulfur, just by chance, we have 16 protons, 16 electrons, and 16 neutrons. All right, now remember I told you the atomic mass was the mass of the nucleus. Guess what? We can check ourselves. If I add the number of neutrons to the number of protons, I should get the number 32 because That's our atomic mass. And sure enough, 16 plus 16 is 32. Electrons are really, really tiny, much smaller than protons and neutrons, so they don't really have an effect on the mass of the atom. It's just the protons and the neutrons. All right? I want you to pause the video and try this one on for size. See if you can fill in the table for this one. All right, so I've given you a few minutes to think about that and to work through this problem. So first of all, what is the name of the element with the symbol Pb? Well, we talked about it earlier in the video, and it's right here on the board. If you didn't use the board and you used your periodic table, it may have taken you a minute to find it, but you would have discovered that the element with the symbol Pb is lead. Okay, so let's write lead in our name column. Okay, now using the information from the periodic table, we have instantly in front of us the number of protons and electrons. So how many protons did an atom of lead have? Perfect, 82, because 82 is the atomic number. How many electrons does an atom of lead have? Exactly, 82, because 82 is the atomic number of lead, and the atomic number tells us the number of protons and the number of electrons. Okay? Now the tricky part. How many neutrons are in an atom of lead? Well, let's do some math. So, we need to do atomic mass minus atomic number. All right, I'm going to round this to the nearest whole number, and because the decimal is in the tens place is a 2, then that means I'm going to keep this at 207. Because this number is much closer to 207 than it is to 208. Okay, so I'm going to use the atomic mass of 207, which was given to me here in the table, 207. I'm going to subtract from that the atomic number, 82. All right, so 7 minus 2 is 5, and I have to borrow, so we've got 10 minus 8, which is 2, bring down the 1. All right, so how many neutrons are in an atom of lead? There are 125 neutrons in an atom of lead. Now, I told you at the very beginning that there would not always be the same number of neutrons as there were protons and electrons. Any idea why that might be okay to have more neutrons than you have protons in the nucleus? So, does a neutron have an effect of the overall charge of the atom? No, neutrons are neutral. They don't have a charge. So we can have as many or as few neutrons in our nucleus as possible, and it doesn't change the behavior overall of that element. Okay, it still will have enough positive charges to balance out its negative charges. Okay, so I can verify that. I can see that 82 positive charges balances with 82 negative charges for protons and electrons. I could also check to make sure that 125 neutrons makes sense for the atomic mass by saying 125 plus 82, and I should get 207. Okay? So again, the purpose of this video was to help us understand how the periodic table provides information to us and what that information means. The atomic number told us the number of protons and electrons. The atomic mass tells us the number of protons and number of neutrons. We can figure out neutrons by doing a little bit of math. We can say atomic mass minus atomic number to get the number of neutrons.